Hello everyone, I welcome you all to this class. This is mathematics class. In this class, we'll be studying implicit differentiation. So we want to know how to find the derivative of implicit functions. That's functions in which the dependent variable is not explicitly known. So I will show you shortcuts. We'll be using shortcuts to finding the implicit differentiation of some implicit function I will be giving to you. Before you use this shortcut to find the implicit differentiation of a given implicit function, you should make sure that everything you have is at the left hand side. You have collected everything at the left hand side, and it's only 0 is at the right hand side. Then we have that the derivative of y with respect to x will be equal to minus open bracket. See what you are going to do. This is what you are going to do. The result of this will be that is, we are looking for derivative of y with respect to x. Derivative of y with respect to x, you are going to put negative sign here at the numerator, then you create a bracket, right? Then inside this bracket, you are going to differentiate this function term by term with respect to what? X. You differentiate the function term by term with respect to what? X. So if you differentiate x raised to power 3 with respect to x, if you bring down the power 3, you have 3x. Then if you minus 1 from 3, you have what? 2. So you have 3x raised to power 2. Then if you differentiate y with respect to x, you are going to get what? 0. So you have plus 0. Then if you come here, differentiate minus x raised to power 2y with respect to x. So you are treating y as a constant. If you are differentiating with respect to x, you treat y as what? A constant. So if I differentiate minus x raised to power 2 minus x raised to power 2y with respect to x. So if I differentiate this, if I bring down the power, I have minus 2x. If I remove 1 from 2, I'll have 1, x power 1. Then I have what? Y. Right? Then if you differentiate 1 with respect to x, you get what? 0. Then all divided by, then at the denominator, you'll be differentiating each of them with respect to y. At the numerator, you differentiate with respect to what? X. At the denominator, you differentiate with respect to what? Y. So if I differentiate x raised to power 3 with respect to y, I will get 0 plus. If I differentiate y raised to power 3 with respect to y, what's the power 3? I'll bring it down. Then I'll write y. If I remove 1 from 3, I have 2. Then coming here, if I differentiate minus x squared y with respect to y, if I differentiate this, you are going to get what? Minus x squared. Right? Then if you differentiate 1 with respect to y, 1 is a constant, you are going to get what? 0. So this gives us what? If I open this bracket with minus, I have minus 3x raised to power 2. Then minus will be plus 2xy. So what we'll have down here is what? What we'll have down here is 3y raised to power 2 minus x squared. Then now we are going to find what? The derivative of y with respect to x at the given point. X is minus 1, y is 1. So x minus 1, y is 1. So this will be equal to, so we'll put x for minus 1 anywhere we see it, to put y for 1. So I put x for minus 1 here, put x for minus 1 here, put y for 1. As up to the given point. Do the same down here. We have 3 open bracket 1 squared minus 1 squared. So I put x for minus 1 here. So simplifying, minus 1 squared is positive 1 multiplied by negative 3. I have negative 3 plus, okay, let's not put plus yet. Then minus 1 multiplied by 1 is minus 1, multiplied by 2 is minus 2. All divided by 1 squared is 1, multiplied by 3, I have 3. Then minus 1 squared is what? 1. Then we have negative here, we have negative 1. Negative 3 negative 2 is negative 5. Divided by 3 minus 1 is 2. So the result of this is negative 5 divided by 2. So thank you so much for being part of this class. See you in our upcoming class. I will solve more examples on this.